I have everything graded in Canvas up through chapter 13. So unless you've done it since 9 o'clock this morning, I think that's, or 9:30 is when I quit grading. But everything's up. Okay. Now I haven't graded the test. Some of y'all have taken the test, but I haven't graded it. Oops, we did that already. This is the shortcut method. The adjusting IV flow rates is where we're at. Before I get my pen clicking on that. So I guess we're ready to be rolling. Okay. All right. So with adjusting flow rates, what we're doing is we're taking, I want to say this. We've got IVs going, and they're gravity flow IVs. So we check them hourly or every couple of hours, but sometimes they're controlled by a roller clamp that will either slow it down or let you speed it up. And so you have to count your drops to get this going. But anyway, so when you check it, you look, you got like a number 15, we have 1,000 milliliters of IV fluid that we're supposed to run through a patient's body. I can't draw a straight line to save my soul today at all. And it's going to run for 8 hours. All right. So you look, you have 600 milliliters remaining. And this is at the 4th hour. So at the 4th hour is after 4 hours. Okay, so after it's ran for 4 hours, we have 600 milliliters remaining. If it's only supposed to run for 8 hours, it's already ran 4, that's half the time, right? So we should be halfway through our milliliters. So half of 1,000 is 500. So we should be at 500 milliliters remaining. Well, this is where we have to adjust it because we have 600 milliliters remaining. Okay. It's given us our drop factor, and it's given our what the current IV is set at. So, and I call this our original rate. So our original rate is 21 drops per minute. Now, finding the original rate, it's what we did on Tuesday, where we took the 125 milliliters per hour, multiplied it by the drop factor, then by the time conversion, or either we took the 125 milliliters per hour and we divided it by the drop factor constant to get the original, and that would get us the original flow rate. Well, now we have to find a new flow rate, because we know that we were going to have to adjust it. So our new flow rate, will also known as our adjusted flow rate. So our new flow rate is going to be our remaining milliliters. I can spell, but I swear today, now I'm having trouble with it. Remaining milliliters over remaining time. And then times our drop factor. Times our time conversion, 1 hour over 60 minutes. So we know that we have 600 milliliters remaining, because that's what it told us. We know that it was after 4 hours, so we're going to have 4 hours remaining. Our drop factor is the 10 drops per milliliter. That's a double T there, not an H. And then times, since it's in hours, our hour conversion, 1 hour over 60 minutes. Our milliliters will cancel, our hours cancel, And then I'm going to pull this little stunt. 10 goes into 10 one time, 10 goes into 60 6 times. And I'll say it again and again and again. If you can cancel and you get it, great, do it. If you struggle with it, try to do it with me. Try to do it with the homework. But on the test, multiply straight across the top, straight across the bottom, and divide. Don't do canceling unless you know what you're doing. Because I want you to know the process, and I want you to know it, be able to complete it quickly. But in order to do that, you've got to be sure that you're going to get the right answer. Okay, so I have 600 times 1, which gives me 600. Then I've got a 4 and a 6, so 4 times 6. So 600 over 24. And you would think, as many times as I've done this today, I would know what it was. And I get 25 drops per minute. Okay, so we have our original flow rate. We have what our new flow rate needs to be. In hospitals, they allow only so much of a variation. So this hospital allows a 25% IV flow variation. I don't know if that's all hospitals or if it's just certain hospitals or what, but for this hospital, which is our class, it's going to be a 25% IV flow rate. That's standard. I'm not going to change it to something else. Our patients will always be stable. So, you know, if you're allowed, you can adjust the flow rate. So we've got to find the percent of variation in order to determine whether or not I can adjust or whether or not you can adjust the flow rate. So the percent of variation, you take your new flow rate minus your original, divided by your original, times 100. Okay? So our new flow rate is 25 minus my old, which is 21, my original, then divided by my original, times 100. 25 minus 21 is 4 over 21 times 100. So 4 divided by 21 times 100. And that gives me 19%. So what I want to look at is my 19% less than or equal to the 25% that the hospital allows. And 19 is less than 25. So then it is. So then we're going to go and we're going to adjust the flow rate to 25 drops per minute. Okay. It's a lot of steps. There's a lot of things to do, but it's really not that difficult. Complicated maybe, but not difficult. All right, any questions? Let's do another one of these. And this one's set up in steps, it makes it easier. So the order is lactated ringers, 1,500 milliliters, 1,500 milliliters, IV for 12 hours at a rate of 125 milliliters per hour. After 6 hours, there's 850 milliliters remaining. Describe your action. All right, so we've got 12 hours total. We're checking after 6, that's halfway through. It's 850, half of 1,500. All right, half of 1,500 is 750. So 850 is more. So then I'm going to have to see if I can adjust my flow rate. So it doesn't give me my original flow rate. So I've got to first find my original. Use that color. Okay, so my original flow rate is 125 milliliters per hour. I'm going to do the long way first. I'll do the short cut next. Over my flow rate, which is 20 drops per milliliter, times my 1 hour over 60 minutes. So my milliliters cancel, my hours cancel, and I know 20 goes into 21 time. All right, how come my pen didn't pick up? 20 goes into 20 once, 20 goes into 63 times. So I've got 125 over 3, which equals, I'm going to go ahead and round it to 42 drops per minute. That just looks horrible. Okay, so that's my original flow rate. I needed to add a line in here. Milliliters remaining. Okay, so how much time do I have remaining? If it's 12 hours to start with, and after 6 hours, I'm doing 12 minus 6, so I'm going to have 6 hours remaining. My milliliters remaining is what they told me, 850 milliliters. That's how many, okay? So to find my adjusted flow rate, it's just like we found our original, except that we're using our remaining milliliters over, and I spelled remaining wrong, I know that. ING there, over our remaining time, times our drop factor, which is drops per milliliter, times our time, hour over 60 minutes. So my remaining milliliters is 850. Remaining time is 6 hours. My drop factor is the 20 drops per milliliter. My time is 1 hour, 60 minutes. And I want to do my canceling bit. My milliliters cancel. My hours cancel. 20 goes into 21 time. 20 goes into 63 times. And I'm going to have 850 over 6 times 3, which is 850 over 18. Excuse me. And I get 47 drops per minute. And that's my new, or my adjusted flow rate. Okay, just like before, to find the percent of variation, it's the new minus the original divided by the original times 100. So I've got 47 minus 42 over 42 times 100. So 47 minus 42 is 5 over 42 times 100. Divided by 42 times 100. Try that again, because I got 42%, and I know that's not right. So 5 divided by 42 times 100. Is 11.9%, or it's, you can say 12%. I'm going to go ahead and go with the rounded. Is my 12% less than or equal to the hospital's 25%? and it is. So then we can adjust the flow rate to 47 drops per milliliter or per minute. I can't read either today. So not real bad, maybe? It's a lot of steps. It only gets worse from here. No, it doesn't. All right. So 17, we've got an order for normal saline 2,000 milliliters IV for 12 hours at 167 milliliters per hour. You got a drop factor of 10 drops per milliliter. After 8 hours, there's 750 milliliters remaining. So what are we going to do? All right. We're a little more than halfway here, right? We have 8 hours out of the 12, so we've really only got 4 hours remaining. And I've got 750 milliliters remaining. So out of 2,000, I think I should have more than or less than that. So we know we're going to do something. I think I should have 500, 4 hours left. Yeah, I should have 500, about 500 milliliters remaining. So I want you to find the original flow rate and the adjusted flow rate, and then this percent of variation. So y'all working on your own. You can use the shortcut method if you want to. Okay, so is there any questions? Did we come out with the same thing? I got 29 drops the first time and I realized I hit the wrong button. I got 28 drops for the original, 31 drops for the adjusted. Excuse me, I have 11% for the percent of variation. Excuse me, which means that I can adjust the flow rate to 31 drops per minute. Okay, let's look at 18. It's another one I want y'all to do on your own. And I'm not even going to read any of it this time. So do we all get 0% for variation? When you get a 0% variation, you're not going to do anything. And we could have actually noticed that from the very beginning, that we weren't going to do anything, because it's after 5 hours. I only had 10 hours. That's halfway through. I have 500 milliliters remaining out of 1 liter. 1 liter is 1,000 milliliters. 500 milliliters is half. So I could have told from the very beginning that no action was required, because it was flowing at the exact same rate that it was originally. So I knew my original and my adjusted was going to be the same. Now I want to play a what if game. Oops. I don't need a highlighter to play a what if game. I needed a color. All right, so we're going to say what if. What if my percent of variation was a negative 19%? Okay. The negative 19, of course, is less than 25. But this negative just means that instead of increasing it or adjusting it to a higher rate, I'm going to decrease, okay? Because it's running too fast, so I got to slow down my rate. Instead of it running too slow, it's running too fast. So this would still be, my 19% is still less than or equal to my 25%. So that would still work. But what if it was a negative 37%? Well, negative 37 is still below the 25. But again, we're not going to look at this negative, because that negative still means to just decrease. So we're looking at the 37%. 37% is not less than or equal to 25. So I'm not going to adjust it. I'm going to call the doctor. Okay, doctor, here's what's going on. And I, for some reason, could not spell doctor just then. Because you want to be careful. You don't want to flood the patient's body just trying to get the rest of that in. So if you've got a big enough variation, because there is things, you can drown in your own body fluid. So, and if you oversaturate the body with the IV, then it can kill them, especially if it's a child. There's this old story going, and I think it still goes around, or they still talk about her. There's this woman in Indiana, Iowa, Idaho, one of those I states. I don't think it was Iowa. I think it was Idaho. I think it was Iowa or Indiana. But she was in a contest to see how much water they could drink in a day. And the one that drank the most water won the contest. I don't remember what they won, but it was something big. She was drinking water by the gallons, and she drank so much water that day that she oversaturated her body, and she drowned in her own body, in her own liquid, or her own body fluids. So anyway, that's what you want to be careful of. It can happen. All right, so we have next, which is different than what we've been doing. And it's a different mindset, but it's intermittent IV infusions. We're still looking for flow rate. Okay, I say it's different than what we've been doing. It's different than the adjusted flow rate to some degree. We're just wanting to calculate the flow rate. We're only giving a packet of medication though, okay? So we're only looking at, in this case, 100 milliliters. In this 100 milliliters is a half a gram of medication, but it's already mixed in the milliliters. So we don't have to worry about it. We just know it's in there. And it's to run over 30 minutes. And I've got a drop factor of 20 drops per minute or per milliliter. So I want my number of milliliters over my time times my drop factor. Since this is already in minutes and I've got a drop factor, I'm wanting it in drops per minute, I don't have to do my time conversion. Okay. So if you're given in minutes, you're wanting it in minutes, don't do the time conversion. I'll cancel a zero. That zero cancels that zero. So I've got 200, 100 times 2 is 200, over 3. And that gives me about 67 drops per minute. And that's all there is to it. So that goes back to what we did really on Tuesday. We're just not doing the time conversion. And we're only talking about the, these are IV piggybacks. They run with the main IV. I'm going to skip 20 because it's doing the same thing. Again, if you go back and do 20, all you need is the milliliters and the time and your drop factor. Now, the IV push drugs, or IV push drugs. And I had a video I showed my other class, and it wasn't a good video, so I'm going to see if I can find a video real quick, or at least that same one. Okay, hang on. She's muted. I gotta get y'all over here where you can see her.
Make sure this piece is working, that's compatible. My population, and that I can give it ibuprofen, how much I have to do it, and how long it's taking. So I got my working, I got my ticket on my working, so I know if this is working. Okay, and I just have a 1 milligram here, and it's better. And so what I figured out is going to take 5 minutes to infuse. I've got 5 mils here. So every minute I'm going to put in. My site looks good, using well, I guess it's infiltrated into the skin. And I'm going to alkalize my port. I've done my checks, I've checked my bar, I have checked, so I've done my 3 checks, make sure it's the rotation, my right reasons for giving it. So my IV is running, it's still infusing, okay, 30 seconds, I'm going to let it dry. Here's got my syringe of morphine. I'm going to 0.1 every minute for 5 years. And then put it in here. I'm going to have my watch with my minute hand. So I'm going to pinch my tubing. I'm going to instill 0.1 of the mil. And I'm going to unplug my tubing. I'm going to wait a minute as it's going through. Okay.
I'll do it different than what I was told.
I'll have the tubing in, put the next 0.1 in. Keep this open for a minute, and then it wait.
I'll stop that for right now. Go back to my question. All right, so Ativan is Valium, just so you know. It's not the morphine. But so we've ordered 3 milligrams of Ativan IV push, and that's what she's doing. That's what she was doing in the video. She was pushing it into the IV line. And you're giving it 20 minutes preoperatively. So you're giving it 20 minutes before the patient goes back to surgery, and that's to calm the patient down. Been there. Had to have the Valium. I didn't have to have it. They gave it to me before I had surgery on my ankle this summer. And I was out before I ever left the pre-op. And it was nice. I didn't know anything. So we know that we have 3 milligrams. I have in my bottle or in my vial 4 milligrams per milliliter. And it says the drug literature guidelines of IV infusions is not to exceed 2 milligrams per minute. Okay, so the first question is how much will I administer? How many milliliters? How much will you administer is always milliliters. So this is what we were doing in chapters 10 and 11. I want to know the number of milliliters. So my doctor's order of 3 milligram over 1 times my supply, which is 4 milligrams per milliliter. So 1 milliliter over 4 milligrams. My milligrams cancel. I'm left with 3/4 of a milliliter, which is 0.75 milliliters. So that's how much you're going to have in your syringe. So how much you're going to use. And then the next thing we want to know is over what time. And my time is going to be in minutes. So I still use my doctor's order. And this time I'm going to use my rate in milligrams. Okay, where it's not to exceed, which is I call it my safe rate. So 1 minute, 2 milligrams. So my milligrams cancel. I have 3 over 2 minutes, which is equal to 1.5 minutes. So I'm going to give this at 0.75 milliliters per 1.5 minutes. Okay, now like she was doing, she was giving 1 milliliter every minute, which worked out perfectly because she would give a milliliter, then she'd let it infuse. All right, this is a little harder because you're giving 75 hundredths of a milliliter over 1.5 minutes. An easier way to look at this and what we can look at is our safe infusion time, which in Harrison, in the video scenario, again, was the 1 milligram per, or 1 milliliter per minute. We're going to look at how much would you give over 15 seconds, because you're actually going to kind of, I guess you could give it, I always been told you're going to kind of continuously push it in for 15 seconds. But you can do the same thing she was. You can give it, watch the clock for 15 seconds, and then give the next piece. So how we do this is we're looking for over the number over 15 seconds. So I'm going to take this amount here, the 0.75, the 75 hundredths of a milliliter over 1.5 minutes. So 0.75 milliliters over 1.5 minutes. Then it's times a time conversion again. But instead of being hours per minute, this time it's minutes per second. And there's 60 seconds in 1 minute. So 1 minute over 60 seconds. And since I want to break it down to every 15 seconds, then I'm going to multiply it by 15 seconds. Okay, so my seconds cancel. My minutes cancel. And that leaves me with just milliliters. And then I'm going to cancel my 15 goes into 15 one time, 15 goes into 60 4 times. So that will give me 0.75 over 1.5 times 4. So that would give me 75 hundredths over 6 milliliters. So the 0.75 divided by 6 is 125 thousandths of a milliliter. And you know, our milliliters don't round to, are not calibrated to the thousandths, are only calibrated to the hundredths. So I have to round that to the nearest hundredth. So I'm giving 13 hundredths of a milliliter over 15 seconds. So every 15 seconds, you're giving 0.13 of a milliliter, which is a whole lot easier to calculate, a whole lot easier to count than trying to do it over a minute or trying to do it over a minute and a half. Because you can't just push that whole 75 milliliters in. Some medications will burn the vein. Some will cause irritations. Different things will cause different. That's the reason they've got a time set for it. Okay. Any questions on that one? Okay. All right, let's look at 22. So I have, don't know what that is, 1,500 milligrams IV push every 8 hours. So the order is the 1,500 milligrams. The whatever is 2 grams of powder with directions for directed IV administration. Reconstitute each 1 gram in 10 milliliters. Slowly give over 3 to 5 minutes. Okay, so if I'm giving 1 gram in 10 milliliters, how many milliliters would I have in 2 grams? 1 gram's 10, another gram is another 10, 2 grams would be in 20 milliliters. So my dosage here is 2 grams per 20 milliliters. And if you reduce it down again, you get 1 gram per 10 milliliters. And we're going to give it, they always said to use the larger time, okay? And that's just another safety precaution. Give it no less than 3, but no more than, no more than 5. So again, first thing I have to do is find out how much I'm going to give, which is not milligrams, it's milliliters. So I have my 1,500 milligrams over 1. So which one do you want to use? The 2 grams per 20 milliliters or the 1 gram per 10 milliliters? You use 2 and 20. So 20 milliliters, 2 grams. And it's okay if you use the 1 gram and 10 milliliters. And then since it's milligrams to grams, I've got to do a conversion. 1 gram is 1,000 milligrams. So my milligrams cancel, my grams cancel. I can cancel 2 zeros with the 1,500, 2 zeros. My third 0, I can cancel with the 20. So I'm doing 15 times 2. And 2 times 1 is 2. So it's 30 over 2, which is 15 milliliters. So I'm giving 15 milliliters this time. Next thing I want to know is my time in minutes. Okay. So I'm still using my 1,500 milligrams over 1. I'm using the 2 grams in 20 milliliters, but it's not 2 grams in 20 milliliters. It's the 2 grams over 5 minutes. Which means I have to have minutes on top. So my 5 minutes is on top. My 2 grams is on bottom because it's 2 grams powder and it's my total over the 5 minutes. I've got to do a conversion again, 1 gram, 1,000 milligrams. So my milligrams will cancel, my grams cancel. I've got 2 zeros, we'll cancel 2 zeros. 15 times 5, 75. 2 times 10 is 20. I'm going to give it over 3.75 minutes. So then what I'm going to use is 15 milliliters per 3.75 minutes. So then, again, my safe infusion time, it's over the 15 seconds. How much am I going to give every 15 seconds? So I take what I just found, the 15 milliliters over 3.75 minutes times my time conversion, 1 minute, 60 seconds, and then times my 15 seconds. Now, when you're doing this, your safe infusion time, you're always going to use the 1 minute over 60 seconds and always the 15 seconds times the 15 seconds. So those are just given. My seconds cancel. And I'm going to do this again. 15 goes into 15 one time. 15 goes into 64 times. So I end up with 15 on top, 3.75 times 4, which gives me 15 on bottom. And because my minutes cancel here too. I'm in milliliters, so 15 over 15 is 1 milliliter over 15 seconds. I'll give her 1 milliliter every 15 seconds. We doing okay? It's a lot to take in today. Percent of variation and IV push, it's a lot to take in. All right. So let's look at the 23, which is the last one for the IV push. And I'm going to let y'all work it. Okay. So did we get 25 hundredths of a milliliter every 15 seconds? Any questions anywhere? Well, this is where we're going to stop today. I think I've kind of overwhelmed your brains. We'll pick up with IV infusion time and volume, and that's the last section. We broke it down into 3 parts for chapter 15. So Tuesday we'll come back and finish up chapter 15 and start on chapter 16. In your textbook, find the review sets for the percent of variation and the IV push, and do some extra practice on those so you'll be good at those. And then I will see you all on Tuesday. Have a good week or good weekend.